This WAEC question. The diagram shows the positions of 3 points x, y, and z on a horizontal plane. The bearing of y from x is 312 degrees and that of y from z is 022 degrees. If distance xz is equal to 32 kilometers and distance zy is equal to 50 kilometers, we have to calculate correct to 1 decimal place the distance xz. So we start by identifying the distance xz. Of course, we make it up to be a triangle like this. Let's make it to be a triangle like this. Okay, something like that. Something like that. Sorry, mind that error. Okay. So we want to find this distance. Of course, as conventional, this is the distance y, small letter y, for it is because it's facing the angle capital letter Y. This place will be called x, and here will be called z, small letter z. Okay, so now we have to find this distance, small letter y, small letter y. Okay, how do we go about that? Let's first consider that the fact that this 312, that is the bearing of y from x, standing at x, observing y. So the angle turning around all this towards x, to the line going to x, is 312. So we need to get this small angle in this corner here. Of course, that balances 360 degrees. So to get that small angle there, we can simply say 360 minus 312. Okay, to get that angle there, and that basically equals to 48 degrees. So that's the value of this angle here. Okay, that's 48 degrees. Alright, but we know that this angle here, if you consider alternate angle this way, C or Z, you'll see that this place will be 48 degrees also. Also, considering the alternate angle at this junction, another alternate angle there, this angle 22 here, this place is 22 down here, and of course this place is also going to be 22 degrees. So the total of this angle is 22 plus 48, and that's 70 degrees altogether. So when we have a triangle like this, in which we have two sides, 50 kilometers and 32 kilometers, and the included angle 70 degrees, the angle between them, the angle between the two known sides is known. Of course, cosine rule is sure to use there. So let's use our cosine rule. We start by saying y squared equals to x squared plus z squared minus 2xz cos y. That's where we start from, and then we begin to impute the values. By saying y squared, or we call it xz, distance xz squared, or simply y squared like we've called it before, y squared equals to 50 degrees 50 squared plus 32 squared minus 2 times 50 times 32 cos 70 degrees. Okay, so having written that, always remember that you have to compute this part first. Always compute this part first, compute that place first, so you will not forget what you're doing. So now, having done, let's do this. 50 squared, that is 2500, plus then you do 32 squared, that's 1024 1024 minus all this together, that's 3200. 3200. Make sure you punch the calculator well, do not make any mistake. Anytime you are pressing angle in degrees, cos, sine, or tan, any trigonometric ratio, ensure that the calculator is on degrees, not in radian. Ensure the D is on the degree, the calculator is on degrees. Alright, having done that, and make sure you add up these two places together. Okay, we add that place together. Let me make it colorful here. So we go y squared equals to adding 3500 to 1024, we have 3524 minus 3200 cos 70 degrees, cos 70. Okay, you can compute all these together at once and you get 2429.5355 blah blah blah. Or I choose to write more decimal places than more numbers after decimal, because I'm not near the answer yet. I can't round yet. Please take care. That's what we call premature approximation. You have to be careful, be wary of premature approximation. So don't round, don't approximate yet. Ensure you don't approximate yet. So here your y, taking the square root. Okay, let me change it. Let me make it more colorful here. Ensure that you take the square root of both sides. So that's the square root of 2429.5355. Okay, and that gives us 49.29 kilometers. But we have been told to round to one decimal place. Okay, so to one decimal place you can simply have 49.3 kilometers. Always write the degree of accuracy 1 dp. So that's a beautiful one there. That's a beautiful one. Let's see how the second part of the question. The second part of the question says we should calculate the bearing of z from x. Please take note of that, from x. Okay, so that means we're standing at x, turning from the north of x. This is the north of x, turning at the north of x. Okay, let me use pink here. Turning at the north, this is the north of x, turning until we can see z. So this is the total angle we want to find now, from here down here, because from north of x to the line going to z. Okay, how do we find this angle? Don't forget that we knew the total of here down to z, to the line going to y before, 312. So if by chance we can get this angle here, if we can get this angle, if we can work this angle out, let me call it theta. If we can get the value of theta, then we'll be able to subtract that from 312 to get the required bearing. Okay, so getting that is pretty simple. Let's make our sine rule becomes handy here. Okay, we've used this place before. Let me just continue down here. Using our sine rule, from the triangle we have that y over sine capital letter Y, we can simply say maybe sine 70 degrees over 49.29. Of course, the sine of an angle to the side opposite it is equal to the sine of another angle over the side opposite it. Okay, the ratio is constant for every triangle. Okay, so sine theta over the side opposite theta, and that is simply 50 degrees. That place we call 50 degrees. Okay, cross multiplying to get your value. You can simply say sine theta equals to equals to 50 sine 70 over 49.29. In fact, you can also say theta is equal to arc sine or sine inverse of whatever we get when we compute 50 sine 70 divided by 49.29. Okay, let me just continue up here. Let me continue up there. Now, having done that, we have that theta equals to, please compute your calculator, punch the calculator from here, make sure you compute it well. That will be arc sine 0.9532. You can write more values to be more accurate. And that you have 72.4 to be the value of theta. 72.4 degrees to be the value of theta. And so by so doing, you can simply say that the required bearing, the bearing, or just say the bearing required, the bearing of Z from X is you're simply going to say 312, like we said before, 312 minus 72.4, and that basically is going to give us let me write it in red here so we can see very well. 3, that's 239.6. 239.6. Don't forget, we are rounding to one decimal place. Thus we leave our angle 2 in one decimal place. Okay, 239.6. Okay, 239.6 degrees. Okay, that is the bearing of Z from X. That's the bearing of Z from right. Here's another question. In the diagram, AB equals to 8 kilometers, BC equals to 13 kilometers. The bearing of A from B is 310 degrees, and the bearing of B from C is 230 degrees. Calculate correct to three significant figures. A, the distance of C from A. B, how far east of B is C is. This is a WAEC question. Alright, when you have a question like this, I advise that you first imagine it. Of course, observe that this question has a diagram. When it has a diagram, it's partly solved. It's solved to an extent. So let's see how we go about the solution. It's very simple. Alright, the diagram is already there. So I have a draft here. In this draft, this is how it is. Alright, the first question says we should find the distance from distance of C from A. Distance C from A. Okay, if you were to name this, if you were to write the letters, I can write this is small letter B, capital letter B. The side facing that is small letter B, so I can write B. CA is going to be C, of course. AB will be side C, and BC will be side A, small letter. Alright, so having done that, we can see that since we have from the diagram we've been given some distances. Let's see those parts that have been given. We have been given BC to be 13 kilometers. Let's write it in the diagram. Writing it makes it a lot easier. We have BC to be 13 kilometers. We also have AB equals to 18 kilometers. I'm just writing in the diagram. So because I've the letters outside the diagram. So here AB equals to 8 kilometers. Alright, so we are asked to find BC. We're asked to find C, the distance C from A, that is small letter B, is what we're looking for. Now in any triangle, of course, like I advised earlier, you must have learned all your trigonometric tools. I call them tools, of course, cosine rule, sine rule, Pythagoras theorem, and all that. So if you observe, in this shape we have an angle. Let's see the angles of that triangle that we have. We using alternate angles. We have 50 up here. The place that is 50 up here is alternate to this other angle here, and so we can write 50 degrees here. Also, since we have 40 in this corner here, from north to west, that is 90 degrees. So that means the other corner here is 50 degrees. Another 50 degrees, another 50, making another 50 degrees, making the whole of this angle be 100 degrees. 100 degrees there. So when we have two sides and the included angle, the 100 degrees is at the middle, is in the middle of the two known sides. That means cosine rule is said to be used. So let's use cosine rule. Let's see how we use cosine rule. The cosine rule here, we're going to find it useful. We're going to find it a lot handy. All right. We say b squared is equal to a squared plus c squared minus 2ac cos capital letter B. Yeah. So having written that, we have that b square that we are looking for, the square of the angle we are looking, the square of the side we are looking for, equals to, thank God I've labeled the sides before. We have the square of 13. We have 13 squared plus 8 squared minus 2 times 13 times 8 cos 100 degrees. Of course, you should know that the negative here will go to multiply, to compute one after the other. Let's compute step by step. Make sure you press your calculator well. Be sure so to avoid mistakes. Okay, so we have square of b equals to 13 squared, that's 169. 169 plus 64 minus, now everything after the minus here is multiplication. And remember your board mass. Please be careful when you get to this place. You don't handle it wrongly. What you do there is just 2 times 13 times 8 first. 2 times 13 times 8, and there we have 208. 208 cos 100. Of course, from here you can just compute 208 cos 100 together. 208 cos 100 together. Of course, you can even go ahead and just add 169 to 64. 169 plus 64, that's 233. 233 minus 208 cos 100 degrees. So this is what I'm saying. Make sure you don't subtract by mistake. 233 minus 208. 208 cos 100 together. Of course, you can even compute everything together in the calculator. If you do that, you're going to get 269.2, that's 269.1. Okay, let me still write more figures. 113. Of course, because that's not the final answer, so I don't have to round from here. You can just leave the answer on the calculator. That's b squared, don't forget. Now, what you're going to do now is b equals to, taking the square root of both sides, b will be equal to the square root of 269.119. and that basically gives us what's the square root of that? That gives us 16.4 kilometers. 16.4 kilometers. And we have been told to round our answer to 3 significant figures, so that's why we round our answer to 3 significant figures. That's the first part of it. That's the first part of the question. So we've been able to figure out that the value of B here is 16, approximately 16.4 kilometers to 3 significant figures. Question says the bearing of C from A. Okay, sorry, we omitted that part the first time. It says calculate the bearing of C from A. Alright, anytime we hear the bearing of C from A or something like that, always go to the word from A, and note that place. Okay, the question says the bearing of B from A. So note this word from A here. That basically means that if we stand at A, okay, imagine you're standing at A, and of course you face the north of A, and you are trying to turn clockwise until you are facing B. Okay, so that means we turn this way until we face the line that goes to C. This is the line that goes to C. This is the line. Okay, so this angle in this corner here is where we are basically looking for. Okay, so let me call that theta. So we are looking for angle theta. That will be the bearing of C from A. Alright, now you can figure out how to get the value of theta anyhow you want it. I've said earlier, you must know your trigonometric tools like SOHCAHTOA, everything that is important, the trigonometric ratios and all that. You should be versed in all that. Okay, but a way to get this angle is to first get this angle C in this triangle, angle ABC in that triangle. Let me call that angle alpha. And see how that is done. Let's make use of our sine rule. Sine rule, we know the AB is 8, so I will simply substitute the values. Let's just say sine alpha over AB rather, that's 8 kilometers. You don't need to put unit again, just write that, equals to, now we can make use of sine 100 degrees over B, and our B, don't forget, we found it in the previous work, that is 16.4, but don't forget we rounded that earlier. It's just 16.405 because I'm using it now. I can't use the rounded value. 16.405. Alright, working along with that, you cross multiply and get your, of course, your sine theta. Let me come down here. Sine alpha rather. Your sine alpha is equal to 8 sine 100 over 16.405. Press that in the calculator. Press that in your calculator, and then take your arcsine. Arcsine of alpha becomes the arcsine of that other side. Whatever you get there, basically you're going to get alpha to be equal to 28.7 degrees. That would be the value of alpha. Having done that, of course, that's not the end. That's not the end. We now say that now that you have found this angle up here, you found this angle, you agree with me that here is 50 degrees, this place is 50 degrees, and we found that alpha equals to 28 degrees. The total of here, that is from here to here now, is 28 plus 50, and that is alternate to this angle here. If you look at it, you have your alternate angle. So where I'm looking for this theta is equal to alpha plus 50. alpha plus 50 degrees. So the theta, the angle we are looking for, is equal to 50 degrees plus 28.7 degrees, and that basically gives us 78.7 degrees. You can write that, since we are writing our bearing, the required bearing is in 3 digits. You can write it as 079, like approximately to the nearest whole number, 079 degrees. Okay, that is that. The last part of the question says, how far east of B C is? Oh, by the way, before we go to the third one, I also want to say that the second one could be done in, of course, you can figure it out in any way convenient for you. Like, for instance, instead of you finding this place we call alpha, you could have found this angle here, this angle in this corner here. Of course, you could use sum of angles in a triangle, or by the way, instead of using sine to get this alpha, you could use sine rule to get this angle here directly. After getting this angle, don't forget that you have your alternate angle this way. So that means this angle is 50 also, 50 degrees. So adding this place plus 50 degrees, taking it away from 180, you're going to get this place that we call, this angle that we call theta. So that's just another way you could think of it. You could figure it out in your own way. Now the third part says, how far east of B C is? We should calculate how far east of B. East of B, east of B. That is, staying at B, the east of B goes like this, alright? The east of B, okay, how far you're going to go to for you to be directly on the sea? Okay, of course, if you look at it, you could form a right angle triangle from it. You could form a right angle triangle from it, and of course, you've got to label this place to be right angled so you can remember. So labeling this distance east of B that we're looking for, x. Okay, so we're looking for that distance. We want to find the distance. Don't forget that this place is 50 degrees, this angle there is 50 degrees, and we have this hypotenuse of that triangle to be 13 degrees, to be 13 kilometers. Okay, so if you know your SOHCAHTOA very well, don't forget your trigonometric ratio, SOHCAHTOA. Okay, I said all this will be useful, very, very useful. Okay, so using your SOHCAHTOA, the appropriate one, you see the opposite x and the hypotenuse there, 13. So that is sine. So we can say sine 50 degrees equals to x over 13. Okay, working with that, you can cross multiply and have your x to be equal to 13 sine 50 degrees. And of course, if you punch the calculator to get the value of that, that is 9.96 kilometers to 3 significant figures. So that is that about that question. It's very simple. Let's go to another one.